Hi, here's how you take the integrals of the 6 trigonometric functions sine, cosine, tangent, cotangent, cosecant, and secant. First, I understand that there's tons of tutorials out there. Therefore, if I can't be a help, then I'd highly recommend you checking out Professor Leonard, Patrick JMT, the organic chemistry tutor, Professor Dave Explains, et al. I am fully aware that I may not be able to reach through to every single person watching this. I'm definitely not proclaiming that I found a breakthrough in teaching, nor am I the best tutor in the world. I just simply want to help out the best I can, and teaching is my passion. So let's get started. The integrals of the 6 trigonometric functions. Now, from what we recall from the fundamental theorem of calculus, derivatives and integrals are inverses of one another. So if you have a function and you take the derivative of that function, then if you take the integral of the derivative, you get that original function back. Contrastingly, if you integrate a function and then take the derivative of the integral, you get that original function back. So to begin, let us recall what the derivative of sine of x is. The derivative of sine of x. Well, that is cosine of x. I'm not going to be drawing the graph of sine, cosine, and the inverse sine to prove this. That's not what this video is about. So the derivative of sine is cosine, and the derivative of cosine x is negative sine of x. Okay, so if the derivative of sine is cosine, then if we were to take the integral of cosine x dx, can't forget the dx, it just says that we are integrating with respect to x, that's going to equal sine of x plus the constant of integration. So the integral of cosine x is sine of x plus c. And to prove it to yourself, take the derivative of sine of x plus c. The derivative of sine is cosine plus a constant is 0. Okay, and therefore you have cosine back. The derivative of sine is cosine. Okay, so that checks itself. Now what about the derivative of sine of x dx? Okay, well that isn't going to be cosine of x plus c, because it's not going to be that, because if you take the derivative of cosine of x, that's going to be negative sine of x. So you have to put a negative in front of the cosine x, because a negative times a negative is a positive. So the derivative of negative cosine is negative sine of x. The two negatives turn it into a positive, and you get the original function back. So those are like the two easiest ones. The next two easy ones would be tangent and cotangent. So let's take the integral of tangent x dx. Now, how can we integrate that? Well, we're going to have to use a property that we learned right from trigonometry class. Tangent x equals sine of x over cosine of x. Okay? And now we use U-Substitution. Okay, we are going to let u equal, always let it equal the denominator in these types of problems. Let u equal cosine of x, and just cosine of x, and du is going to equal the derivative of cosine of x, which is negative sine of x dx, can't forget that, and then I multiply or divide by -1 to get the negative on one side, on this side. And notice that you see a sine of x dx here, and you have a sine of x dx there. So you could substitute this for negative du. And I'm going to pull that -1 du, I'm going to pull the -1 outside. So that's going to be negative the integral. Now sine of dx is du. Okay, we could substitute in u for cosine x, and that's in the denominator, and that's going to equal to negative natural log of u plus c. Okay, got it in there. Okay, don't forget it's the absolute value. Okay, natural log has to be a non-negative, so 0 and above. If you use the power rule and say that this is u to the -1, you're going to get a 0 in the denominator. That's why you have to remember that if it's like 1 over u, or if it's 1 over x, or whatever variable you're in respect with, it's going to be the natural log, the absolute value of that variable. Now we just plug back in right there, and therefore the integral of tangent is going to equal negative the natural log of cosine of x plus c, the absolute value of cosine of x plus c. That is the integral of tangent. This is the integral of sine, and this is the integral of cosine. And of course you could take the derivative to make sure to prove it to yourself. And that is how extraordinary the fundamental theorem of calculus is. So now let's take the derivative of cotangent x dx. Okay, that's going to equal, well, if we said that tan equals sine over cosine, well, cotangent equals cosine over sine of x dx. What's in the denominator now? Sine. So we let u equal sine this time. And the derivative of sine is cosine x, don't forget the dx, which is found right here. So this is going to equal the integral cosine x dx becomes a du. 1 over sine of x becomes 1 over u. You don't have to worry about any of the negatives. Okay, that's going to equal the natural log of u plus c. That's going to equal the natural log of the absolute value of sine of x, because u equals sine of x plus c. And that is the integral of cotangent. Okay. Now, the two hardest ones. Okay, it's not really that hard or so, but in fact, you could just memorize what the integral is, than having to do the problem over again. But this is how you derive it. So if the professor asks you, don't just tell me what it is, actually derive it. This is what you do for taking the integral of d of x. Notice that if we take something like arbitrary, like an a, and we multiply it by 1, that's going to equal a, right? Okay, if we take a and multiply it by 1, okay, that's going to equal a. So 50 over 50 equals 1. So we're going to multiply this by 1, but a special type of 1. The integral of secant x times. Now, to do this, I want us to recall, what is the derivative of secant x? Well, the derivative of secant x is secant x tangent x. We are actually going to multiply with what I had actually written. So the derivative of secant x is secant tan. So we are going to multiply this not by secant tan, but secant x plus tan of x. And you divide that by secant x plus tan of x dx. Isn't that the same thing? Isn't this 1? Secant x times 1? It is. And you're going to, or that's going to equal the integral. Now you just distribute in the secant x. Okay, that's going to be secant squared x plus secant x tan x over secant x plus tan x. And I understand if this looks like it's not going to go anywhere, but trust me, it will be. So we're going to, just like normal, or just like before, we're going to do U-Substitution. We're going to let U equal the denominator. And then when you take the derivative of that, du equals, well, the derivative of secant x is secant x tan x, plus the derivative of tangent x is secant squared x dx. And look at what we have here. We have du, okay? And this becomes a u. So we have this equals to, that becomes du, and this 1 over secant x plus tan x becomes 1 over u, which equals the natural log of the absolute value of u plus c, which equals the natural log of secant x plus tangent of x plus c. Just like I was saying in the beginning of the video, like, I'm not claiming to be the best tutor. I don't have all tricks that everyone could grasp. I mean, some people could grasp these mnemonics, other people can't, and I understand that. And that's why if you go to another place, I mean, if you're confused by this, if you go to another place, that person might make more sense to you. What I want to say here is that if you are taking the integral of secant x, if you know that the derivative of secant x is secant x tan x, all you have to do is just put a plus in between here, put absolute values around it, put a natural log in front of it, and plus c, and there you go. Okay, one more. You know, sine and cosine sort of goes hand in hand. Tan and cotangent goes hand in hand. Well, what do you think? Secant and cosecant also goes hand in hand. I believe I have just enough room. Cosecant x dx. Now, we're going to multiply by another special one. I guess you could imagine what that one is. First, take the derivative of cosecant x, just to visually be able to prove it to yourself. The derivative of cosecant x is going to be negative cosecant x cotangent of x. Okay, what's the cofunction of secant? Well, cosecant. What's the cofunction of tangent? Cotangent. Okay, so but I guess by this chapter you already memorized that. So that's the derivatives. So this time I'm going to have my 1. I could have negative cosecant x plus cotangent x, or you might as well put the cotangent in front and you subtract it by cosecant x. Okay, and then you divide it by the same thing, cotangent of x minus cosecant of x dx. Okay, then you just distribute, and that's going to equal cosecant x cotangent x minus cosecant squared x divided by cotangent x minus cosecant x dx. Okay, and like before, we let u equal the denominator, and we let du equal the derivative of cotangent. It's going to be negative cosecant squared x. The derivative of cosecant, well, minus, the derivative of cosecant is negative the derivative of cosecant, negative cosecant cotangent. That negative is going to turn that into a plus. Cosecant x cotangent of x, which it's right here. So do you see that that minus negative turned it into a positive? Just make sure that you understand that. Dx, which this right here is that right there, okay, and this is our u. Therefore, we have this equals 1 over u du, okay, which equals the natural log of u plus c, equals the natural log of RU cotangent x minus cosecant x plus c. And that is one valid answer. Some people use algebra to make this into a plus and that into a minus, so negative natural log of the absolute value of the quantity cotangent plus cosecant x plus c. That's a valid answer too. And this is how you do it. Take the integrals of the 6 trigonometric functions. So like while you're taking this class, what your major is, what your passion is, just don't give up on them. Practice is key. Take what you're learning, take your building blocks through basic calculus, and when you apply calculus, when you apply physics and such, if you understand this before, then everything else will relatively get easy because you have a strong foundation. Just don't give up on your studies or whatever you want to do in life. And thank you for your time. It's appreciated, and have a nice day.